shape in the mirror line.
Yeah.
How would you do it? So let's say this point.
So it's 1 square away from the line. So then on the other side, you go 1 square away from the line and draw the dot there.
And how about this one?
Then it's 2 squares diagonal up. So you do it 2 squares diagonal up.
Like...
You know how it goes across 2 squares?
Oh, okay.
So
Yeah, and I'd probably just use the same method for everything. So if you say two squares across and up,
yeah.
like you might accidentally do it there or something, I don't know. Basically, this one is 3 away. Like this is 3 to the right of the mirror line. So then just do 1, 3 to the left of the mirror line.
Oh, right.
So the same method as the blue one, and then just join them up.
Yeah.
So you don't have 2 methods to remember. You can just do the same thing. Where would this point be?
It would be the same. It would be on the mirror line, and then the other one would be 2 squares away from the mirror line.
That's it. So 1, 2, 1, 2, and that one, yeah, it's 0 away from the mirror line, so that stays where it is. And then we join these up. Okay, so that's pretty straightforward. This one is the same idea. Sometimes, so these are all the past exam questions. Sometimes there's a different line that they want you to reflect it in, and it's exactly the same process. So that's like 1, 2, 3 to the right. So you do 1, 2, 3 to the left, and so on.
Yeah.
Okay, how about this one?
So that point is 2 away from the line that we're using.
And so which one is the y-axis?
The y-axis is the line going like vertical line, the vertical one.
Yeah.
Yeah. So it's like, yeah, so then you go 2 away.
Yeah. And it's exactly the same as the other ones. If that one's 4 away, so 4 away, and so on. And then you join them up. Let me just check. No, that's 5 away by accident. There we go. And then you join those up. Okay, so that's mirror line, then just random line, then y-axis. So that's 3-sided shapes, 4-sided shapes, exactly the same idea. If it's a rectangle, exactly the same idea, except there's now 4 corners to do it on.
Yeah.
The method is exactly the same. Okay, how about this one?
X1. I'm not really sure you'd do this one.
So you'd need to draw the line x equals -1. So you go to the x-axis and you go to -1 on that x-axis. And so it would have to be, although it's x equals -1, it has to be a vertical line. And basically that's because all of the x coordinates are -1. So -1, 0, -1, 1, -1, 2, -1, 3, -1, -1, -1, -9, and so on. Okay, so let's say, how about this point? What would you do there?
Well, it's 2 squares away. No, 3 squares away from the line, so you go 3 away.
Well done. Yeah, and then just the same for every other thing. Okay. So, and then this is more than 4 sides, but the same idea. The shapes get a bit more complicated, but the same method.
Yeah.
How would you do it if it's a diagonal line?
Basically, if say we're looking at the bottom right corner, it's only a line away. So then, would you do from the no? Actually, no, it's half. Yeah. So you can see that can you see that it goes across the square, and so there's like a triangle?
Yeah, so it's like a half a diagonal away.
Would you put the other one on that? Actually, no, I don't really know.
So there's a few different ways to do it. I think the easiest way is with a mirror line, you're always going at a right angle to it. So you're doing it like directly
Yeah.
across. And you do the same for this one. And so this is half a diagonal away. And so you go half a diagonal on the other side. So basically like that.
Yeah.
So let's say, so that would be there. How about this corner here?
Would it be instead of, because it's to the left on that one? Would you have to go to the right?
So I would just use the same method. So how many diagonals away from the mirror line is this?
2.
So 2 would be here.
Oh, 1.
And 1 would be here.
1.5.
Yeah. And so it's 1.5 away from the mirror line. And so you go another 1.5. So that's 1.5. And so a half and 1. And so that's the reflection. And then how about the one up the top?
Is it 2.5 away from the mirror line?
Correct. So that's 1, 2.5. And so a half, 1, 2. Put it there. And then you just join up your 3 dots. So that there, that there. And you can see how it's rotated it. And so you'd probably never get that.
Yeah.
So yeah, just follow the same method. If it's 2 squares to the right, you go 2 squares to the left. 2 squares above, you go 2 squares below. And in this case, if it's 2.5 diagonally away, then you go 2.5 diagonally on the other side.
Yeah.
Any questions about that? Okay. This one, where would the mirror line go?
It would go 2 away from each shape, like the line that's 2 away.
That's it. So that would go there. Label your mirror line M, so we just stick an M under it. Okay, how about this one?
I'm not really that sure how you do this.
So you have to just say what transformation has happened.
Oh.
So your answer would be a sentence.
The shape, the bottom of the shape's moved 4 squares to the right.
Do you know the name of these types of transformations across a mirror line?
No.
So these are called a reflection.
Yeah.
And so this is a reflection, and what was it reflected in?
A mirror line.
And where is the mirror line for this one?
The y-axis.
Correct. And so this is a reflection in the y-axis. And so if we had for the other ones, just want to go to the earlier ones. Yes, this one. So this one here, if they asked you to describe it, and they had the whole thing, it would be a reflection in the line x equals -1.
Yeah.
And that's how they work. Okay. Okay, how about this one?
Yeah, you got to shade I don't even know how to explain that. I know what one it is though. You know how there's 3 on the left and there's only 2 on the right?
Yeah.
You got to that one. Yeah, that one.
That's it. Okay. And then your thing would be there. And there are, yeah, so actually 3 different places you could have done it. There, there, or there. I think you'd be fine for that. Okay, draw all the lines of symmetry on this rectangle.
There's one going vertically down.
Yeah.
One going across. Is there one? Is there 2 going diagonally across the shape?
So I'll just do that. So if you folded this diagonal, would it go on top of the other one?
No.
No, it would go like a bit up here, and then this one would go a bit down there. So yeah, rectangle only has 2. That's it. Okay. A line of symmetry for this one?
There's one down the middle.
Yeah. And how many would there be in total?
There'll only be 2.
What does it mean by regular, a regular pentagon?
I don't really know.
It means that all sides are the same length.
Oh.
And so because of that, you could spin it any which way you want. And so this one would have even more. And so that would be exactly the same as the one we just did. So would that one, so would that one, and so would that one. So if you have a regular pentagon, which just means a regular 5-sided shape, because it has 5 sides and they're all the same length, it will have 5 lines of symmetry in total.
Oh.
Okay, all the lines of symmetry for this one.
One down. One across. Would there be some going diagonal as well?
So all sides are the same length. So what do you think?
Yeah, sure, it'd be going diagonal.
Yeah, that's right. And so if all sides are the same length, then this will be the same as the previous one. So this is 4 sides, so it'll have 4 lines of symmetry. The last one had 5 sides, all the same length, so 5 lines.
Yeah.
Wait a second. 1, 2. A line of symmetry. Let me just look at this. That's clearly correct. Look at that. That's clearly a line of symmetry.
Yeah.
Let me just look at this question for a second. Draw all the lines of symmetry. All sides. Hang on. This quadrilateral has all 4 sides the same length. I think we're correct. I just want to bring this down here. If I was to spin this, so let's say like that, and you have to do it at a right angle. I mean, that's just so symmetrical, isn't it?
Yeah, I don't know why that's not right.
That's totally...
That would be the same on both sides.
Yeah, that's totally... Okay, I don't know. It's from an exam paper. One of these shapes has exactly 2 lines of symmetry. Which shape?
Is it... Is it A?
So A has one like that. Where will it have another?
Actually, no, it's not A.
So A has one.
Could it be... Could it be C?
So C, diagonally, is it?
Yeah.
It doesn't look like it. That looks like it'll fold kind of that way. And even straight down doesn't work for C, because that would fold here. I think this has 0.
Yeah, no. Don't know if it's B or not. I don't know what it is, to be honest.
So B, that's definitely one line of symmetry, and I don't think you can get one across that will work. So that has 1. How many does E have?
2, doesn't it?
Well, it's going to have 1 going straight down, but then none will work this way. The top half is bigger than the bottom half. D?
You can go straight down the middle, actually. Down the middle, horizontally.
Yeah, and so this one has 2. So this was straight down and straight across. D. Any questions there?
No.
Okay, so D, just have to try them all. One shape has no lines of symmetry. Which one is that?
A.
Let's see that. A. Looks like A. Hold on. How many lines of symmetry does this have?
It only have 1, wouldn't it?
I think it's 1, yep. Straight down. Yep. I think you'll be fine for that.
Yeah.
Draw all the lines of symmetry. I think you'll be fine for that. How many lines of symmetry does shape C have?
Just 1.
Just 1, yep. How about this one?
Four.
That's right. So they asked us to draw them on, so I'm just going to draw them on. 1, 2, and then these diagonals that way. 3, 4. That's it. So 1, 2, 3, 4, and that's 2 marks. All 4 lines. Draw a line of symmetry. Draw a line of symmetry. Okay. How about this one?
These patterns. It's just... It would be A.
I believe it is. I think you're fine for this. Okay, let's try this one.
Top. No. Yeah. Like, you know the right of the mirror line at the top?
Yeah.
You could shade that in.
Okay. Yeah, go on.
Shade the one at the bottom. And then, yeah, it's the same. No, not that one. To the left of the mirror line. No, it's the same.
No. This one has a white here, but then there's no white there.
Oh, so you got to shade that one in as well.
Okay.
And I'm pretty sure you got to shade one of them at the top as well. The last square at the top.
Okay. Yeah.
Yeah, that's it.
So you've got 3 white here and then 2 white here.
Oh, you got to shade one of them in as well.
Okay.
And you've got to shade on the left. There's another square. Got to shake that out.
That's it. That's it. So you've just got this ring here, and that's it. Okay, how about this one?
Down, cross, with 2 diagonals be one side.
I think so, because all 4 sides are the same length.
Yeah. Yeah, that's it.
Yep. Let's change back to blue. The shape that has 1 line of symmetry.
Yeah. Pretty sure it's C.
Looks like it's C. B or C. Yeah, I thought B as well.
Yeah.
Okay. What letter has 2 lines of symmetry?
A.
Yeah, well done. You got that complete. Oh, what is this insanity? Work out the total number. Yeah, that's just going to be lots of shading and stuff. How about this one?
1 down.
So this is kind of weird. They should have told us if the sides were the same length or not.
I mean, I think that's it.
That's it. If all 3 sides are the same length, then there would be those 2 as well. I just don't know if they are.
Yeah.
Okay, I might have cut out the top of the question where it says all 3 are the same length. Okay, how about this one?
I don't special name of this quadrilateral. Is that a rhombus?
Correct. And so a rhombus has 4 lines of symmetry. Same thing. Name of this shape?
That a trapezium.
Yep. Name of this shape?
Octagon.
Yep. Name of this shape?
Hexagon.
Yeah. Name of this shape?
Parallelogram.
I believe so. This one?
Is that a trapezium as well?
Yeah. You'll be fine there. You'll be fine there. You'll be fine there. Okay, how do you draw a kite?
So from the top you go, I think it's two diagonal.
Okay.
And on the other side as well. And then you join it along at the bottom.
How?
Like, you draw a diagonal line going to... You see where the point is at the top?
Yeah.
You go down that line to the bottom, but don't... You see at the bottom of that line here, you just join it up. See how it's...
Okay, yeah. Yeah, exactly. So long as these 2 lines on the bottom are longer than the top. Otherwise it might make a rhombus. Okay. How do we do this one?
Could you the two squares? So you see how there's four square shades at the top, but only two at the bottom.
Yeah.
You just shade the two underneath that, like that one, yeah, and the one, yeah, that one.
I think that would make rotational symmetry of two, or of one. Sorry. Like it would just have more like a mirror line. I'm not. I just want to skip to something else. Hang on. What would be the order of rotational symmetry for a regular pentagon?
I don't really know what that means, to be honest.
Okay, so that's what I was checking. So basically, it means if you were to rotate the shape around, it's like around itself. How many times would it go? Would it spin perfectly back on top of itself? So if you had like its center point there, and you were to spin it around, how many times would it spin perfectly on top of itself? So that's the spin point there. Any ideas?
Not really.
Let me just do this thing. So I'll put blue line, red line, green, yellow, and black. And so basically, if you were to spin this around about its center point, so it's kind of, I can't do it perfectly, but if you were to spin this around its center point, basically, if you spun it a little, so the blue square would then be exactly where the red square was, then exactly where the green square was, then exactly where the yellow square was, then exactly where the black square was, and the black line was, and then back on top of itself.
So, like, for this, the rotational, would it be 5? Because the blue line will go along.
Yeah.
Yeah.
Yeah. So it's like the way it in a similar way that it has 5 mirror lines, it would spin on top of itself perfectly 5 times.
Yeah.
Okay, shade 1 square. So this has rotational symmetry order 2.
Would you shade, you know, the square second from bottom? Would you shade the square to the right of it?
Correct. So shade in there. Order of rotational symmetry for this one.
Is it 1?
If it's 1, then that's the same as 0. You just say it's 0.
Oh, so 0.
So if I was to put its center point like there, and I was to spin it around 180 degrees.
Actually, no, it'd be 2.
Yeah, that's right. Yeah, because it would spin perfectly on top of itself. How about this one?
That's 8.
Yep. How about this one?
2.
I think it's 2. Yep. This one?
6.
Mm-hmm. Okay, 2 shapes have rotational symmetry order 2. Which 2 shapes is that?
E's one of them.
Yeah.
So is I don't think it's B, but that's the only other one I think it could be.
I think it is B, because if you spin that around, this corner would go exactly there,
Yeah.
and then it would go back to where it was, and so that would be 2. Yeah, B and D.
Yeah.
So it's a shame I can't perfectly spin it. So order of rotational symmetry for this one?
2.
Yeah, so a parallelogram has rotational symmetry order 2. And then this one I can't do on the computer, but rotate this shape 90 degrees anti-clockwise about a point. So if you were to rotate it 90 degrees anti-clockwise, so that would be anti-clockwise is this way.
Yeah, you just turn it to the side.
Yeah. So 90
Yeah.
degrees is like quarter of a turn. So it'll end up looking like that. So on its side, pointing that way. And so how would you do this if you had... How would you go about doing this one if it was on paper in front of you?
With tracing paper or not?
Yeah.
Draw the shape
Mm-hmm.
in the tracing paper, and then I'd pick a point, like any of the points, and then I'd go to... No, actually, I'd pick the center,
Mm-hmm.
and I'd put the shape on 0, 1, turn it 90 degrees, and then draw in the shape.
That's it. So you just put your point on 0, 1 after you've traced it.
Yeah.
And you turn it, and it'll be somewhere, I don't know, somewhere around here or something. Yeah. -1, 3. So -1, 3. Okay, so it's a little to the right. Okay, how about this one?
Two.
I think it's 2. Yeah. How about this one?
I think this one's actually 4.
So I think the problem is there's 2 whites here.
Actually, no, it's not 4. 2. Yeah.
I think it's 2 as well. Let me just check. 1, 2, 3, 4, 5, 6. Yeah, so it's 6 by 5. So it's always going to be 2. How about this one?
This one would be 2.
Mm-hmm. 2 shapes have rotational symmetry of order 2 and no lines of symmetry.
H is one of them.
I don't think so. I think the other corner would have to be cut out like that as well. Because if you turn it around, it won't be the same.
Yeah. E.
I think definitely E.
Yeah. And is it G?
I think it has to be G. Yeah. Yep, G and E. Order of rotational symmetry for this.
5.
Yep. Okay, so how about this one? Quarter turn clockwise. That's kind of difficult to describe. 1, 2.5. So that's 1, 2. So, and this one is 1, 2, 1. That's 2 diagonals. 2 diagonals, and then you just join them up. It'd be easier with tracing paper. It's just difficult to do.
Yeah.
On the computer, and I'll do like that. Okay. Okay, enlargements. I'll come back to that. How would we do this one?
Right. So, I am not too sure.
So this side here is 2 up, and let's say the base is 3. So if you have to enlarge it by a scale factor of 3, you multiply every side by
3.
3.
So that would be, 6.
Yeah, so this is going to now go 6 up.
Okay. 9 across.
And then I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what else? What would I do next?
Then you go, so it's 2, you go 6 diagonal.
So it's not a perfect diagonal.
Oh. Don't know what you'd do.
You could do the other side.
You could just go 6 across.
And then?
And then join them up.
Yeah, and so for the last side, it's you know, do all the easy sides and then the difficult one. Okay, so scale factor 3, multiply all the sides by 3. Okay, let's try this one.
So go 3 up. 6 across. Then 6 diagonal.
See, it's not a... This is very difficult. Let's say this one here is 1 right and 2 up. So it's 1 right, 2 up.
So would you go 3 right, 6 up?
Yeah. I hope I have enough room. I do. So 1, 2, 3 right, 1, 2, 3, 4, 5, 6 up. Yeah. And last side.
And then you join them up.
Yeah. That's it. Okay, so we did, that's the hardest type. So that times 3 equals 3 right and 6 up. Draw all the lines of symmetry. That's okay. Symmetry. We did it. I just want to go back to the one I skipped over. Slow down, slow down. This thing has a mind of its own. Okay, how about this one?
It would be 2.
This one?
2.
Okay, they're all very similar.
Yeah.
Okay, that's that one, and I just want to skip over to this other one, but I think we've done the guts of it. So we did the reflections. Just count the spaces for how many away. Diagonals. This is the one I wanted. Go back, go back. I'm pressing back. It's still going forward. What do I have to do? Any idea how we do this one?
No, not really. Actually, I think I do. Is the top one down or across?
Top one is X, bottom one is Y.
Alright, so you'd move 3 to the left.
Yeah.
Right, and then 2 up.
Yeah. And you do the same thing for every corner. So 1, 2, 3, 1, 2. 1, 2, 3 left, 1, 2 up. And then just join them up. And that's it. Okay. And sometimes they want you to label it, like label it P or M or something.
Yeah.
Okay, how do we do this one?
You go 3 left,
Mm-hmm.
1 down.
Yeah.
Okay.
Just do the same for every corner. 3 left, 1 down. 3 left, 1 down. And then join up. You'll be okay there. How about this one?
Yeah, 5 right,
Mm-hmm.
2 down.
Yeah. And same method for every corner. You know, you can always try. What you can probably see is that the shape isn't changing. Like it's not getting bigger or smaller.
Yeah.
Do you know the name of this transformation?
Oh no, sorry, I've forgotten.
Translation.
Translations.
So a translation is just a slide. Enlargement, obviously, it gets bigger or smaller. Reflection, you know what it looks like, mirror line. And I think that's it. Move the square force to the left.
To the left.
There. How would you? Okay, how about this one?
Check you. I am honestly not too sure.
So, you would need trace and paper. Basically, how has the shape changed from from Q to R? Was it an enlargement?
It's rotated.
Yeah, so this is a rotation.
Yeah.
How much did it rotate by?
90 degrees.
And in which direction?
Clockwise.
From Q to R?
Oh, anti-clockwise.
Yeah. And so the last thing you would have to say is, remember for the other one they said the center of rotation was 0, 1, and we said like you'd put your point down on that. So for this one, you would have to trace Q and then just point your point down. You'd start at 0, 0, put your point down there, and then see if you're too low, too high, and then change where the point is. You know, go back to the start, change where the point is, and see where it would be. But it's very common for it to be on 0, 0. But for the rest of the stuff, it rotated, so it's a rotation. It turned 90 degrees in the direction anti-clockwise. And then you just use like put your tracing paper down and try different points to find the center of rotation. So in this case, it was 0, 0 that they rotate around. Any questions about that? That's one away. That's one away. Okay. Let's try this one from B to C.
It was rotated anti-clockwise.
By how many degrees?
90.
Anti-clockwise. And then you would just, same thing, trace B, put your point down in different places and see where it would work, and always start with 0, 0, and we can see that the answer was 0, 0 again. This is pretty common. Okay, describe this transformation.
It was rotated clockwise 180.
180 degrees, and then we'd need to trace it and try different spots. And this was 0, 1. Okay.
Yeah.
Okay, how could we do this?
I am not too sure.
So we needed to. Let me try a different one. How about order 2?
Could you just shade the 2 top ones and the 2 bottom ones?
So let's say I shade these 2.
Oh, right, yeah.
And so what other 2 would I shade?
The ones in the bottom left.
Correct. Yeah. So bottom left. So that would, if you spun that around, it would be perfectly on top of itself. Twice. Okay, so then how about order 4?
Could do top left one.
Okay.
Then the one across from that.
Like opposite it?
Yeah.
Okay. And then
the one on, so like there's like a one sec, so like there's a 1 sector gap in between it. That one, yeah.
okay. And the last one?
The one across from it.
Yeah, well done. And so that will, as it spins around, it'll be perfect on top of itself 4 times. Okay, so that one's rotation symmetry order 4, and that's rotation symmetry order 2. Enlargements, scale factor 2, we did it. Scale factor 3, so you can see the shapes are a bit more complicated, but it's the same exact idea. How do we do the? No, I think you'd be fine for it. I just want to make sure there's no other thing. Scale factor 3. Let's do this one.
Mm. 30.
Yes. And then how about next one?
Would be 120.
And what do the 3 angles in a triangle add up to?
180.
And so if you multiplied them all by 3, then they'd add up to 540.
Oh.
And so what does that tell you?
No, it can't. Do you just keep it the same?
Correct, yeah. So for an enlargement, the sides are multiplied by the scale factor, but all the angles stay the same.
Yeah.
So 30 and 40. Scale factor of enlargement. We looked at it. Scale factor of enlargement. Oh, this one. What type of describe the transformation here?
It's been what's it called when you change the size of it?
Can you remember?
I can't remember.
Enlargement?
Yeah, it's been enlarged.
Okay. What else can you say about an enlargement?
By 3.
So scale factor 3.
Yeah.
And this one might just, I think this one is just for the higher paper. You have to say the center of enlargement, and to do that you join up matching corners.
Yeah.
Let's see, and you just see where they cross over. So these two, those two corners match up with each other. These two corners match up with each other, and they're both going through 0, 0.
Yeah.
So basically, if you match up all the corners, they'll all go through 0, 0. And so basically, for this one, the center is 0, 0. But I don't think you need to worry about that.
Yeah.
Enlargement, rotations. Yeah, did it. That's it. So, just want to make this. So what's a translation? What's the difference between them?
Translation. That's where it tells you to move the shape, and so you do it.
Yeah, so that's like a slide, and it's always by a vector.
Yeah.
Reflection.
Reflections when you there's usually a mirror line, and you've got to basically draw the shape on the other side.
Yeah, just count the sides.
Yeah.
Oh, sorry, count the squares away. Yeah. And how about enlargement?
Enlargement is such a change in the size of the shape by a certain amount.
So, change size of shape by a scale factor. Yeah. And what would you do with the angles?
The angles, you keep them the same.
And you keep the angles the same. That's it. What is rotational symmetry?
Rotational symmetry is seeing how many times the shape fits into itself.
Yeah. And reflection symmetry?
Reflection symmetry is it's like how to explain this one.
Let's just say
it's the same as rotational symmetry, but you've got to draw extra things on the shape. So, yeah.
Yeah, so basically like how many mirror lines the shape has.
Yeah.
How many mirror lines it has. Shape has. Yeah, so that's literally all of transformations, I believe. Yeah, how is that for you, Mikey?
It's good, thank you.
Is there anything in particular you want to do next time?
No, I don't really mind what we do next time, to be honest.
Okay, I'll pick something. Do you have any questions for me in general?
No, thank you though.
Okay, well then, Mikey, you did great. I look forward to talking again next time.
Alright, I'll see you later.
Alright, have a good one. Goodbye.
See you later. Bye.